In the silent ocean beyond our world, there are places so strange, so haunting, that even the bravest telescopes hesitate to look too long. The universe spreads itself before us like an endless shadowed sea, and yet, for all the wonders we have named, there are countless others still hiding in the dark. We point our instruments outward, sending beams of radio and light into the abyss, and the abyss answers only with silence. It is in that silence, that strange, unyielding quiet, that the most unsettling mysteries begin to take root. Every great journey, every exploration begins with a question. Ours is deceptively simple. What truly waits in the dark between the stars? The stars themselves, after all, are beacons. They shine. They speak. They make themselves known, their light crossing unimaginable gulfs to reach our eyes. But the spaces between them, the dark regions that stretch farther than imagination can comfortably grasp, those are the places that unsettle us most. They are the gaps in the story, the pages torn out of a cosmic book. Imagine for a moment that you are standing at the mouth of a cave. In your hand, a torch glows weakly, its flame trembling against the weight of the dark. For a few meters, you can see the stone, rough and wet, glistening under the light. Beyond that circle of vision, however, lies pure obscurity, a blackness that could hide anything, or nothing at all. That is what space is like, only instead of meters, the darkness stretches across eternity. Instead of stone, it is a void that resists even definition. When astronomers raise their telescopes to the heavens, they are holding that trembling torch, revealing only fragments of a mystery so immense that the very act of looking becomes overwhelming. Humanity has mapped continents, oceans, and skies. We have cataloged galaxies, traced the swirling arms of the Milky Way, and sketched the faint outlines of clusters so distant their light has been traveling toward us since before Earth itself was born. Yet for all that knowledge, the great between, the interstellar and intergalactic night, remains a canvas of unanswered questions. There are regions in the universe so empty that no atom dares to linger. Voids spanning hundreds of millions of light years where galaxies themselves retreat from view. There are fields of dark matter, invisible scaffolding that holds the cosmos together while refusing to reveal what it truly is. Even here, close to home, in the faint glimmer of nearby stars, there are mysteries we cannot unravel. What happens inside a black hole? What lies beneath the surface of a rogue planet? Where, if anywhere, does the story of life repeat itself? It is easy to think of space as something distant, detached from our daily lives, but the truth is more intimate. Every breath you take, every atom in your body, was forged in the hearts of stars. To ask what lies between the stars is to ask what lies at the edges of yourself. The abyss is not only out there, it is in here, woven into your very being. You are a fragment of this mystery, a question folded into the fabric of existence. And this is where the strangeness deepens. The more we look into the cosmos, the less certain we become. At first glance, the night sky appears clear and orderly. Constellations draw familiar shapes. The moon waxes and wanes. The planets wander slowly, predictably, across the ecliptic. But beyond that surface calm lies turbulence beyond imagining. Stars tear themselves apart in bursts of gamma fire. Quasars roar with energies that eclipse entire galaxies. Black holes lurk in silence, distorting time and light. The universe is not still. It is not safe. It is a restless, boiling sea, and our little torch reveals only glimpses of the storm. What makes this so haunting is not only the danger, but the incomprehensibility. Human minds evolved to track the flight of predators, to follow the rhythm of seasons, to measure distance across valleys and rivers. Our ancestors never needed to hold numbers like 1 billion in their heads, let alone billions of light years. Yet here we are, trying to picture infinity, trying to imagine what 100 trillion stars might look like, or what it means for time to stretch forward without end. The cognitive dissonance is staggering. It is like asking a candle to illuminate an ocean, or a whisper to fill a canyon. The deeper we look, the stranger it gets. Each answer we find gives birth to more questions. Each discovery opens into another mystery. When Edwin Hubble first showed that the universe is expanding, it raised a new, unsettling possibility. If space is expanding, then what lies beyond it? When physicists measure the cosmic microwave background, the faint echo of the Big Bang, they find patterns, fluctuations, anomalies that suggest hidden rules, or perhaps hidden worlds. And each of these findings leaves us not with clarity, but with wonder tinged by unease. Take a moment to sit with that unease. Close your eyes and imagine yourself floating in the dark, no Earth beneath you, no stars within reach, just endless black stretching in every direction. The quiet is total. Your own heartbeat is the only sound. Would you feel awe or terror? Perhaps both, woven together into something new. That is the feeling the universe gives us when we dare to stare too long into its hidden corners. It is not merely scientific curiosity. It is the raw encounter between human fragility and cosmic enormity. This is why the mysteries of space matter. They are not distant puzzles for astronomers alone. They are reflections of the boundaries of human comprehension, tests of how far imagination and reason can stretch before they break. To confront them is to confront the limits of what it means to be alive, aware, and temporary in a universe that feels eternal. We may chart the orbits of planets and the lifespans of stars, but we cannot yet chart the edge of comprehension. And perhaps we never will. Perhaps that is what makes the darkness so profound, so haunting. Not that it resists light, but that it resists answers. And so, we stand here at the threshold, the doorway into darkness. Behind us, the familiar world, warm with sunlight and life. Before us, the abyss, whispering with secrets we cannot yet name. It is not a question of whether we will step forward. We already have. Every photograph from Hubble, every detection of a far-off exoplanet, every map of the cosmic background is a step deeper into that cave. The torch still flickers, the walls still stretch into the unseen, and the darkness still waits. And perhaps the most chilling entry point into these mysteries, the one that will guide us forward into the rest of this journey, is the idea of absolute nothingness. What if, hidden between the stars, there is not merely absence, but a deeper void? What if emptiness itself is not what it seems? Not all of space is crowded with stars. In fact, most of it is not. What fills the universe is not the glittering brilliance we admire in the night sky, but emptiness beyond emptiness, vast chasms where matter itself seems unwilling to dwell. We look up and imagine the heavens ablaze with light. Yet this is an illusion born of perspective. Stars shine, but they are rare, scattered jewels against a backdrop of immeasurable dark. The deeper astronomers peer, the more they find that the universe is mostly nothing, an abyss with only islands of fire suspended within it. These regions of absence are called cosmic voids, immense expanses that stretch across hundreds of millions of light years, barren of galaxies, barren of stars, barren of anything at all. If the cosmos is a web, filaments of galaxies strung together in a lattice of light, then the voids are the empty holes between those threads. To sail through one would be to enter a gulf so lonely, so devoid of form or presence, that even imagination falters. Picture yourself on an ocean, adrift for weeks. The waters stretch without end. You expect at least the splash of a fish, the tug of a current, the faint sound of wind. Now imagine discovering a stretch of water where even those small movements are gone, where everything is motionless, silent, and still. That is what a cosmic void is, silence. Not of moments, but of eons. The first time scientists realized how large these voids were, it shook their understanding of the universe. In 1981, astronomers mapping the distribution of galaxies stumbled upon what became known as the Botez void. This cavern of nothingness is nearly 330 million light-years across. Within its borders, where one might expect tens of thousands of galaxies, there are only a handful, like faint lanterns trying to illuminate an abandoned city. It is one of the largest known structures of emptiness in the observable universe, and yet it may not be unique. There are many such voids, scattered like empty rooms inside an unfinished mansion, reminders that the cosmos is not as full as it first appears. Why should such voids exist at all? Some theories suggest they are scars left from the earliest days of the universe. In the first moments after the Big Bang, matter was not evenly spread, but clustered, leaving behind great hollows where density was low. As galaxies formed, they gathered along the filaments of the cosmic web, and the voids became even emptier, emptied further by the gravitational pull of surrounding structures. Other scientists speculate that unknown forces may be at work, subtle energies or exotic particles shaping the large-scale structure of the cosmos in ways we barely comprehend. To stand at the center of such a void, if such a thing were possible, would be to stand inside a silence older than galaxies themselves. Take a moment to imagine that experience. No nearby suns to warm your face. No planets circling quietly in the dark. No galaxies to mark the horizon. Just black in every direction, an absence so complete that even time might feel slower, stretched thin by the sheer vacancy around you. What would it do to the mind to live in such a place? Would the silence crush thought, or would it open a new kind of clarity? A realization that in the face of so much nothing, existence itself becomes unbearably precious. The haunting nature of voids is not only their emptiness, but the questions they pose about reality. If the universe is mostly nothing, then the something we cling to, the stars, the galaxies, even our own lives, is the exception. Matter is rare, fleeting, fragile. The void is the rule. This shifts our understanding of what it means to be alive. We do not live in a universe filled with light, but in one where light is rare, where darkness reigns. The stars we see at night are not signs of abundance, but of scarcity. They are sparks struggling against an infinite silence. Philosophers and poets might find meaning in such a thought, but scientists, too, are unsettled. If cosmic voids are natural outcomes of physics, then they hold clues to the very birth of the universe. By studying their shapes and distributions, researchers hope to test theories of dark energy, to glimpse the fingerprints of forces that drive expansion itself. The voids are not merely absences. They are canvases upon which the greatest mysteries are written. Their emptiness is information. Their silence is a kind of language. And yet, the more we learn, the more unsettling it becomes. Some simulations suggest that voids are growing, that as the universe expands and galaxies rush away from one another, the spaces between them stretch into ever wider deserts. If so, the universe is not becoming more crowded, but less. Over unimaginable timescales, even the familiar constellations we know will dissolve, their stars slipping beyond our sight. Future observers, if there are any, may find themselves staring into a sky emptied of neighbors, marooned in an ocean with no shore. Pause with that for a moment. Imagine yourself far in the future, perhaps billions of years from now, gazing upward. The Milky Way has drifted apart, the nearby galaxies no longer visible. All around is dark, starless. For the inhabitants of that time, the universe will appear empty, stripped of its history, its vastness erased by the silence of expanding voids. What would it mean to live in such a cosmos? To inherit a sky that hides the truth, where the memory of abundance is gone? Cosmic voids invite us to reflect not only on astrophysics, but on solitude. They embody a silence so complete that it presses on the imagination. If we could stand within one, we might come to understand loneliness in a way no human has ever experienced. Yet at the same time, they remind us of connection. For even voids are not absolute. They have edges, borders where galaxies still cling, threads of light strung against the emptiness. To know the void is to appreciate those fragile connections more deeply. The nothingness gives meaning to the something. The silence gives meaning to the whisper of light. In the end, the voids are not empty of wonder. They are, paradoxically, full of it. Their expanses challenge our sense of scale, our understanding of what it means to exist. They remind us that the universe is vast beyond comprehension, and that our place within it is both infinitesimal and extraordinary. To float at the heart of such a space would be terrifying, yes, but it would also be sublime, a confrontation with the ultimate silence that shapes all things. And yet, even this silence is not the deepest terror the universe can offer. For while voids haunt us with their emptiness, there are places where the universe does not merely fall silent, but collapses entirely, folding in on itself in ways that defy reason. The void may unsettle us, but it pales compared to what lurks inside black holes. They are not stars, though once they were. They are not planets, though their gravity can anchor whole systems. They are not even objects in the usual sense. They are places where the rules of existence itself falter, where space-time bows so deeply inward that no force, no light, no thought can climb out again. These are black holes, the hungry shadows of the universe. A black hole begins with a death. A star many times the mass of our sun burns hot and bright for millions of years, but its fuel cannot last forever. When the core exhausts its supply of nuclear fire, Gravity wins. The star implodes, collapsing under its own weight. In an instant, matter that once resisted with fusion's blaze is crushed inward, tighter and tighter, until nothing can withstand the pressure. For some stars, the collapse halts as a neutron star, a city-sized sphere of incomprehensible density. But for the most massive, there is no stopping. The collapse continues until space-time itself folds into a point of infinite density, a singularity. Around this singularity lies the event horizon, the one-way boundary of no return. Imagine standing on a cliff's edge, so steep and so smooth that once you step off, you cannot climb back. The event horizon is that cliff, but made not of stone, but of space-time. Anything that crosses it, whether a photon or a planet, is gone to the outside universe forever. To an observer watching from afar, objects falling toward the horizon appear to slow, stretching into elongated ghosts, red shifting into invisibility, as time itself seems to freeze them at the brink. But from the perspective of the falling object, the plunge is swift and absolute. Inside, physics as we know it breaks. Distances and times lose meaning, and what happens at the singularity is hidden from us. The equations that describe nature refuse to cooperate here, diverging into infinities, suggesting either the limits of our knowledge or the hint of a deeper framework waiting to be uncovered. And yet, for all their violence, black holes are not merely cosmic destroyers. They shape galaxies. At the heart of nearly every large galaxy, including our own, lies a supermassive black hole with millions or billions of times the sun's mass. These monsters do not simply lurk, they orchestrate. As matter falls into their grasp, it whirls into luminous accretion disks, heating to extraordinary temperatures, outshining entire galaxies. Jets of plasma, accelerated to near light speed, erupt from their poles, stretching for thousands of light years, sculpting interstellar space and regulating star formation. The hungry shadows, in their feeding, help decide where and when new stars will shine. But perhaps the most haunting thing about black holes is not their appetite, but the questions they leave behind. Consider the fate of information. Physics rests on a quiet principle. That information, the description of a system's state, can never be truly lost. If you burn a book, its words vanish to the eye, but the ash, smoke, and heat still encode the details of what once was. Scrambled, yes, but not erased. A black hole seems to break this rule. When something falls in, its structure, its history, its every atom is swallowed beyond the horizon. From the outside, all that remains is a few numbers: the black hole's mass, its spin, and its electric charge. The rest, it seems, is annihilated. This puzzle, known as the black hole information paradox, is not a trivial detail. It is a direct clash between quantum mechanics, which insists information survives, and general relativity, which declares the horizon absolute. For decades, physicists have wrestled with this contradiction, suspecting that its resolution might demand a new understanding of reality itself. Stephen Hawking once proposed that black holes leak, that through a subtle quantum process at their edges, they emit faint radiation, now called Hawking radiation, and slowly evaporate. If true, even the mightiest black holes would eventually shrink to nothing, leaving only a puff of radiation behind. But if they vanish entirely, what becomes of the information they consumed? Is it released in scrambled form with the radiation? Is it stored holographically on the horizon itself, etched into the very surface like cosmic graffiti? Or is it transported somewhere beyond our reach, perhaps into other universes hidden from view? Each possibility rewrites the rules we thought unshakable. The paradox has inspired theories stranger than science fiction. Some suggest that the universe itself is a hologram, that the three-dimensional world we know is an illusion projected from two-dimensional information inscribed at its boundaries. Others imagine wormholes, secret tunnels that connect one black hole to another, allowing information to pass through unseen. Still others see black holes as seeds of new universes, each collapse birthing a separate reality where the information lives on, unreachable from our own but not truly gone. And what of those who dare to imagine falling in? For a human traveler, the experience would depend on the size of the black hole. In a small one, tidal forces, the stretching of gravity, would be so extreme that you would be torn apart long before reaching the horizon. Scientists call this spaghettification, an oddly whimsical word for such a dreadful fate. But in a supermassive black hole, the horizon lies so far from the singularity that you might cross it without immediate destruction, gliding silently past the boundary with no sense of doom. Only later, deeper in, would the fatal stretching begin, the inexorable pull toward the singularity. To outsiders, you would never truly vanish, your image forever frozen at the horizon. To you, the end would be swift, absolute, and unknowable. For all their menace, black holes are not merely agents of fear. They are invitations to wonder. They force us to confront the fragility of our understanding, the provisional nature of our knowledge. They show us that the universe is not a solved puzzle, but a living riddle, one that resists simple answers. In the shadows of black holes, we glimpse the edges of human comprehension. Perhaps that is why they haunt us so. They are mirrors of our own ignorance, cosmic reminders that we are creatures peering into darkness with a trembling torch. We name them, we model them, we simulate their behavior on supercomputers, but we cannot yet say with certainty what they truly are. They remain both familiar and alien, terrifying and necessary. Without them, galaxies might not form as they do. Stars might not be born in the patterns we know. The universe itself might lack its present structure. In a strange way, we owe our existence to these hungry shadows. And so the question lingers. Are black holes graves or gateways? Do they consume or do they conceal? Perhaps the answer is both, or something stranger still, something we have yet to even imagine. What we do know is this: each time we turn our gaze toward them, each time we listen to the faint tremors of space-time as black holes collide, sending gravitational waves rippling across the cosmos, we step closer to unraveling the mystery. But if black holes are the universe's darkest secrets, then what do we make of the things that refuse to stay quiet, that do not collapse inward, but instead erupt outward in cataclysmic defiance? There are mysteries stranger still. Mysteries that do not swallow the cosmos whole, but explode with a violence that shakes creation itself. If black holes are the silent devourers of the universe, then gamma-ray bursts are its sudden blades, unsheathed without warning, cutting across the cosmos with fury so sharp it seems designed to remind us of our fragility. There are no explosions on Earth that can compare, no storm or detonation we can summon that even remotely echoes the violence of a gamma-ray burst. In a fraction of a second, a dying star can unleash more energy than our sun will emit across its entire lifetime. Imagine all the warmth and light that has bathed Earth since life began, concentrated into a flash so fierce it could sweep away worlds as if they were sketches drawn in sand. Gamma-ray bursts, or GRBs, are among the most luminous events known to science. They erupt from the deaths of massive stars or the collisions of neutron stars, their power compressed into narrow beams of high-energy radiation. For most of the universe, they pass unnoticed, their knives cutting only the emptiness. But the unlucky path of a beam can sterilize entire star systems. If Earth were caught in such a burst, even thousands of light years away, our atmosphere would be stripped, the ozone shredded, the surface bathed in radiation that would end complex life in a geological heartbeat. The oceans might still stir, the rocks would still circle the sun, but every story humanity has told would collapse mid-sentence, erased by a cosmic flash no one would have time to see. The terrifying thing is how silent it would be. There would be no warning, no blaze across the sky, no signal that apocalypse was at hand. One moment the Earth would be as it is now, alive with cities and forests and oceans. The next, invisible knives of energy would carve through the air itself, undoing eons of fragile balance. Extinction? Instantaneous, anonymous. This is the sword of Damocles that hangs not just over Earth, but over countless planets scattered through the galaxy. Yet these bursts, though monstrous, are not mindless chaos. They are the signatures of transformation. When a star of extraordinary mass burns through its last reserves of nuclear fire, its core collapses inward, perhaps forming a black hole, while its outer layers explode outward in a supernova. In certain rare cases, the collapse channels itself into jets, focused streams that punch through the star's body and erupt into space at nearly the speed of light. The result is a gamma-ray burst, a blade flung across the cosmos, precise in its direction, but devastating in its reach. There is another kind as well, When two neutron stars, stellar remnants themselves, so dense that a teaspoon of their matter would weigh billions of tons, spiral together and collide, the clash sends tremors through space-time. From that wreckage bursts another blade of radiation, briefer but no less fearsome. These short gamma-ray bursts are not just destructive, however, they are creative. For in their violence, they forge heavy elements, gold, platinum, uranium, the building blocks of worlds and of human history. Every ring on your finger, every coin and crown and circuit, carries in it the memory of some distant star's death, some gamma-ray burst that spilled not only destruction but also treasure into the universe. So we find ourselves facing a paradox. These cosmic blades are killers, yes, but also creators. They destroy life in one corner of the galaxy, even as they enrich the ingredients for life in another. In their harshness, they seed possibility. The same radiation that could wipe us from existence also carries within it the fingerprints of the processes that made us possible in the first place. For scientists, gamma-ray bursts are both terror and opportunity. Their brilliance makes them visible across billions of light years, serving as beacons that pierce the fabric of the universe. By studying them, astronomers can peer into the earliest epochs of cosmic history, back to a time when the first stars were dying and galaxies were still young. Each burst is a cosmic flare, an announcement that even in the universe's youth, the cycle of birth and death was already underway. And yet, behind every discovery lies a whisper of unease. For every GRB we detect, how many sweep silently through the void, unseen, their blades missing us by chance alone? The Earth has been circling the sun for 4.5 billion years. In that span, has our planet already been grazed by one of these invisible knives? Some scientists speculate that mass extinctions in Earth's past, sudden collapses of ecosystems, might bear the scars of such bursts. A ray slicing through the atmosphere millions of years ago could have dimmed the shield that protects us from solar radiation, letting ultraviolet light pour in, unraveling food chains and rewriting evolution. If true, then even the history of life on Earth carries the fingerprints of these distant, merciless events. Think about that for a moment. The rise and fall of species, the survival of one lineage over another, might not have been guided only by the slow grinding of natural selection, but also by random blades flashing through the sky, trimming away possibilities before they ever had a chance to flourish. Humanity itself may exist not just because of the favorable tilt of our planet or the chemistry of our oceans, but because we were spared a burst's direct strike. Life's endurance, then, is not simply resilience, but luck, chance woven into the deepest fabric of our story. This realization sharpens our awareness of fragility. We often imagine Earth as a secure haven, a stable home beneath a friendly sun. But in truth, we live inside a narrow bubble of safety, shielded by distance, by probabilities, by cosmic geography we cannot control. Somewhere out there, even now, stars are collapsing, neutron stars are colliding, bursts are flashing. That their blades do not find us is less a guarantee than a miracle repeated daily. Yet in their violence, gamma-ray bursts remind us of something profound: the delicate balance required for life. To exist at all, to persist long enough to think about our origins, to tell stories about the stars, is to be suspended between chaos and order, destruction and creation. The universe does not promise us protection. It offers only possibilities, some nurturing, some lethal. That we are here, breathing and wondering, means that for now, the blades have missed us. And so we are left with an unsettling duality. Gamma-ray bursts are weapons, yes, sharper than any sword, faster than any arrow, crueler than any storm. But they are also signals, messages written in light, telling us of the births and deaths of stars across the cosmos. They carry not only the threat of erasure, but the gift of knowledge. In studying them, we glimpse the workings of the universe's grand machinery. We see how stars die, how elements are forged, how galaxies evolve. We see, in short, how we came to be. But perhaps what unsettles us most is not the violence of the bursts themselves, but the randomness with which they strike. They do not aim. They do not choose. They do not even know that we exist. And yet our existence depends on their absence. This is fragility at its most absolute, life balanced on the knife edge of cosmic chance. Still, even blades can be beautiful. Imagine, if you will, the view from afar, a jet of light erupting from a collapsing star, brighter than a billion suns, slicing through darkness that has endured for eons. It is terrifying, yes, but also sublime, a reminder that the universe is not gentle, but it is magnificent. In its ferocity, it creates spectacles that humble us, that force us to measure our place not in miles or years, but in sheer improbability. Even gamma-ray bursts, with all their violence and splendor, are not the strangest mysteries the universe holds. There are patterns we glimpse, but cannot explain, signals that arrive without origin, rhythms that hint at forces we have yet to name. If the cosmos wields blades sharper than swords, it also whispers in codes we have not yet cracked. And it is in those whispers, perhaps more than in the flashes of destruction, that the deepest hauntings of the universe reside. If the universe is so vast, then why does it feel so empty? This is the riddle at the heart of what has come to be called the Fermi paradox, a question so simple that it feels almost childlike, yet so haunting that it keeps astronomers awake at night. With billions of stars in our galaxy alone, and countless galaxies spread across the cosmos, it seems only natural to assume that life should be common, even inevitable. Yet when we listen for voices, when we scan the sky for signals, all we hear is silence, so heavy it presses against the imagination. The paradox was first crystallized in the mid-20th century when physicist Enrico Fermi, during a casual lunch conversation, supposedly asked, "Where is everybody?" It was not a statement of doubt, but a genuine puzzle. By all calculations, civilizations should be everywhere. If even a tiny fraction of stars harbor planets where life could arise, and if even a smaller fraction of those develop intelligence and technology, then the galaxy should already be humming with communication, glowing with the evidence of distant societies. But as far as we can see, the galaxy is dark. The silence is absolute. Picture yourself in a stadium filled with tens of thousands of people. You take your seat, expecting the roar of voices, the murmurs of conversation, the clatter of movement. Instead, you find yourself sitting in stillness, hearing only your own breathing echoing in the space. The sheer mismatch between expectation and reality is unnerving. That is what the Fermi paradox feels like, only on a cosmic scale. We expect chatter, evidence, signs. We find nothing. Scientists have offered many possible explanations, each both fascinating and unsettling. Perhaps life is truly rare, and we are among the lucky few. Perhaps Earth is not just one of many, but one of the only. Or perhaps life is common, but intelligence, or the leap to technology, is vanishingly rare. Civilizations might rise and fall like sparks, too brief to ever meet one another, burning out before their light can travel far. There is also the possibility that life is common and enduring, but hidden. Perhaps advanced civilizations choose not to broadcast themselves, fearing dangers in the dark. They might live in silence deliberately, concealing their presence as one might hide from predators in a forest. In this scenario, we are not alone, but unheard, the naive newcomers shouting into a wilderness that knows better than to answer. And then, of course, there is the most chilling possibility of all, that something, some law of the universe or some lurking danger, ensures that civilizations do not last long enough to spread their voices. This is often called the Great Filter. The idea that somewhere along the path from chemistry to life, from life to intelligence, from intelligence to spacefaring civilization, there lies a step so difficult, so dangerous, that almost none succeed. We do not yet know if the Great Filter lies behind us, if our very existence means we have already crossed it, or if it lies ahead, waiting, an invisible threshold that few or none survive. The Fermi paradox is not just a scientific question, but an existential one. To ask where is everybody is also to ask what are we? Are we rare? Are we alone? Or are we simply early, the first to awaken in a universe that has not yet had time to fill with voices? Each possibility carries profound implications. If we are rare, then the weight of existence presses upon us, for we may be the only eyes through which the cosmos knows itself. If we are alone, then silence is not an accident, but a truth that stretches endlessly. And if we are early, then perhaps the universe's silence is temporary, and we are standing at the dawn of something vast and inevitable, the first sparks before the fire spreads. Take a moment to sit with that silence. Imagine yourself tuning a great cosmic radio, spinning the dial across billions of frequencies, hearing only static, only emptiness. the hum of background noise that comes not from voices, but from the birth of the universe itself. Imagine pointing telescopes at star after star, finding planets, atmospheres, oceans perhaps, but never the glint of cities, never the shimmer of technology. The void stretches on, indifferent, inscrutable. What emotion fills you? Is it relief that we may be unique, unthreatened, or dread that we may be alone in a universe too vast for company? Even the very act of searching becomes a meditation on fragility. The search for extraterrestrial intelligence, SETI, has scanned the heavens for decades, listening for signals that might betray the existence of distant minds. Now, more advanced arrays and methods deepen the listening, extending our reach into space. Yet every time the result is the same: silence. It is a silence that grows heavier the more we listen, as though the universe itself were conspiring to remind us that we are solitary. But is the silence truly empty? Or is it only a silence we cannot yet translate? Perhaps signals are there, but not in the forms we expect. Perhaps civilizations communicate in modes beyond our detection, through particles or dimensions we do not yet understand. To us, it is silence. To them, it might be a symphony, humming just outside the range of our ears. There is also a poetic possibility, one that blends science with imagination, that we are listening too soon. If the universe is billions of years old, then perhaps intelligent life takes longer to emerge in most places. Maybe we are among the first, the very early bloom of consciousness in a universe that is only now beginning to awaken. In that case, the silence is temporary, a prelude. The choir has not yet assembled, but someday voices will rise and the cosmos will no longer be mute. Yet what unsettles us most is the alternative, that silence is not a prelude, but a warning. If civilizations broadcast their presence, only to vanish soon after, then perhaps the silence is not accidental, but enforced. Perhaps there is something out there that ensures the universe remains quiet, something that silences all who speak too loudly. The thought is chilling, as if the cosmos itself enforces a law of discretion, punishing those who break it. If so, then our own transmissions, our radio waves leaking into space, might already be whispers in a dangerous dark. The Fermi paradox is not only a question of science, but a mirror held to human longing. It reflects our yearning for connection, our fear of loneliness, and our hope that we are not the only minds to walk among the stars. It reveals that we do not simply study the cosmos, we also seek our place in it, our kin, our story among others. And so, we continue to listen, to scan, to search. Each silence we encounter is not the end of the question, but its renewal. Every unanswered call only deepens the paradox. Every unlit world only amplifies the mystery. Yet sometimes, silence is not total. Sometimes, faint whispers reach us, signals that defy easy explanation, bursts of radio waves from deep space, flickers of light that hint at patterns we cannot yet decipher. Whether they are natural or artificial, coincidence or communication, they remind us that even in silence, the universe hums with secrets. And it is in those whispers that the story continues. Across the dark canvas of the sky, every so often, a flare of energy arrives like a shout from nowhere, brief and dazzling, then gone before we can even ask what it meant. These are the fast radio bursts, or FRBs, and they are among the most bewildering signals we have ever detected. Imagine tuning into the silence of space and suddenly hearing a pop, sharp and bright, lasting only a fraction of a second. In that instant, more energy has poured forth than our sun emits in days. Yet it comes and goes with no warning, leaving no trail to follow. The first of these bursts was discovered almost by accident in 2007, when astronomers combing through data from a telescope in Australia stumbled upon a spike of energy that defied explanation. It was as if the cosmos had cleared its throat, a sudden cough of light, then resumed its silence. Since then, dozens, and now hundreds, have been recorded, each one reminding us that the universe is never truly still. They appear at random across the sky, without pattern, without announcement, their brevity making them almost impossible to predict. To understand how strange this is, picture a lighthouse standing on the far side of the ocean, so far away that its beam should never reach your shore. And yet, one night, for a single blink of an eye, you see the flash sweep across your vision. Then nothing. Was it chance? Was it real? Did the beam truly find you, or was it an illusion? This is what FRBs feel like: improbable, fleeting, yet undeniably there. Scientists believe many of them are natural, born in the cataclysms of collapsing stars, magnetars, or the tumult of neutron stars, tearing at themselves with magnetic fields trillions of times stronger than Earth's. These events could explain the sudden spikes of energy, the millisecond pulses that seem to carry across galaxies. And yet, there remains a hint of unease, for some of the bursts refuse to fit neatly into the natural categories. A few repeat, not regularly, but often enough to suggest a rhythm, as though something is trying in its own way to speak. And when patterns emerge in the sky, the human mind cannot help but wonder about intention. Could some of these bursts be signals, artificial in origin, beacons cast deliberately across the void? Some astronomers dismiss this idea as fantasy, yet the whispers remain. After all, if we were to send a message across galactic distances, what better tool than a burst of energy so powerful it could not be mistaken for ordinary noise? For a civilization with technology far beyond ours, FRBs might be the equivalent of cosmic searchlights, brief flashes designed to announce, "We are here." The implications are staggering. If these bursts are natural, then they remind us of the raw violence of the universe. The unfathomable forces that can outshine stars in the blink of an eye. If they are artificial, then they are a message, not necessarily for us, perhaps not even aimed at us, but intercepted by our instruments like an accidental eavesdropping on a conversation meant for someone else. Either way, the mystery deepens. Consider what it would mean to stand beneath a sky alive with these bursts, not seeing them with your eyes, but knowing they are there, hidden in wavelengths beyond our senses. A rain of whispers from galaxies billions of light years away, each one older than humanity itself, each one crossing unimaginable expanses just to end as a flicker in a telescope. If they are messages, then we are reading postcards that were mailed before Earth's continents had even taken their current shapes, before the first creatures crawled onto land. The voices we hear are impossibly old, delayed by the tyranny of distance. To listen is to become a time traveler, catching echoes of things long past, perhaps of civilizations long extinct. And yet, repetition changes everything. In 2016, astronomers detected the first repeating fast radio burst, a source that sent not one, but multiple signals, as if something were pulsing deliberately, insistently. Since then, others have followed, some with irregular rhythms, others hinting at strange cycles. The bursts return like heartbeats, like lighthouses sweeping over and over, refusing to be dismissed as chance. Natural explanations still abound: magnetars, collapsing fields, cosmic storms, but in the gaps of certainty, the imagination stretches. What if they are not storms, but signals? Not accidents, but intention. The beauty of the FRB mystery lies in its duality. It could be entirely natural, yet it tempts us with the possibility of intelligence. The very uncertainty forces us to confront how little we know about communication, about meaning, about the ways life might choose to speak. We look for words, patterns, messages, but perhaps the language of the cosmos is something else entirely. Blinding bursts of energy, designed to be unmistakable across the fabric of space. Philosophically, FRBs remind us of our hunger for connection. Each time a burst is recorded, astronomers race to interpret it, to map its source, to assign it a story. We cannot help but listen for voices, to lean into the silence and imagine that someone might be leaning back. Perhaps that is the true gift of these bursts. Not answers, but invitations to wonder. Take a moment to reflect on that. A pulse lasting less than the blink of an eye carries across billions of years and billions of light years to reach us, fragile yet intact, like a message in a bottle drifting across an endless sea. Whether it is the cry of a collapsing star or the beacon of an unknown civilization, the effect is the same. It reminds us that the universe is alive, restless, and filled with signals we barely know how to interpret. The question lingers. Are these bursts only the aftershocks of dying stars, or are they greetings from minds we cannot yet comprehend? Are we witnessing the chaos of matter, or the order of intention? The silence of the Fermi paradox hovers nearby, and FRBs arrive like whispers breaking through that silence, brief enough to be doubted, powerful enough to be undeniable. Each detection becomes a moment of wonder, a pause in which science and imagination intertwine. We do not yet know what FRBs truly are, and perhaps that is why they haunt us. They are the perfect mystery, both terrifying and beautiful, as fleeting as a breath, yet as powerful as creation itself. But if signals can travel across space, if bursts of energy can leap across galaxies and reach our instruments, then perhaps the universe is not as quiet as it seems. Perhaps it is not only messages that travel the void, but visitors too, carrying their mysteries with them into the dark. And that is where our attention turns next. Not every world belongs to a star. Some have no sunrise, no warm beacon to orbit, no home but the endless dark. They are called rogue planets, and they are the drifters of the cosmos, lonely worlds cut loose from their suns, wandering without direction or destiny. Astronomers suspect there may be more of these dark nomads than stars themselves, an invisible population of planets slipping silently through the void. If stars are the fixed lighthouses of the universe, then rogue planets are the ghost ships, moving with no crew, no anchor, no harbor to return to. To picture one, imagine a frozen giant drifting in blackness. Its skies are always night, pierced only by the distant glow of galaxies. Its seas, if it has any, are hidden beneath crusts of ice thicker than mountains. Winds sweep across frozen plains, not driven by sunlight, but by the slow leaking of heat from the planet's own heart. Volcanic vents might glow faintly under layers of ice, like lanterns burning in catacombs, and deep beneath there may even be oceans, cradling secrets in their dark waters. Such worlds would never know seasons, never know the rhythm of dawn and dusk, only an endless twilight. How does a planet lose its sun? Sometimes gravity itself plays the villain. In the crowded youth of solar systems, giant planets can jostle smaller ones like marbles on a tilted floor, half flinging them outward until they escape their parent star's grip entirely. At other times, a close brush with another star can tear planets away, stealing or banishing them in the violence of encounter. These exiles are then doomed to wander between galaxies, frozen and forgotten, carrying their histories with them in silence. The strangeness lies in their abundance. If estimates are correct, there may be trillions of rogue planets drifting through the Milky Way alone. For every star that anchors a family of worlds, countless others roam untethered, silent witnesses to the drama of creation and destruction. And most of them remain invisible to us, their presence betrayed only when they briefly pass in front of distant stars, bending light with their gravity in fleeting signs we struggle to detect. Take a moment to imagine standing upon such a world. The sky above would not blaze with a sun, nor even glow with reflected moonlight. Instead, there would be blackness so pure that every star in the universe would shimmer in sharp relief. Without the veil of atmosphere scattering light, the cosmos would appear overwhelming, a dome filled with fire. Yet the ground beneath your feet would be ice, hard and unyielding, silent except for the groaning of shifting crusts. You would not feel the warmth of morning, only the faint heat rising from deep within the planet's core, like embers hidden under ash. And here lies one of the great mysteries. Could life exist on such worlds? To us, life is bound to sunlight, to photosynthesis, to warmth from above. But life, as far as we know, can also thrive in darkness. On Earth, entire ecosystems exist in the abyss of our oceans, where no sunlight reaches, fed only by the chemical energy of hydrothermal vents. If rogue planets harbor subsurface oceans, heated from within by radioactive decay or tidal stresses from hidden moons, then life could thrive in their shadows, utterly independent of stars. We may imagine strange creatures swimming beneath frozen shells, never seeing light, never knowing a sky, yet surviving, generation after generation, in perpetual night. The thought unsettles us, because it means that life may not need the comfort of stars at all. It may not need the stage of a warm planet in a habitable zone. It may arise and persist in places we would never think to look, adrift in black space, hidden from our telescopes. And if life can exist there, then it may exist everywhere, silently, secretly, in worlds cast off and forgotten. There is another, darker implication. Our Earth, for all its apparent stability, is not immune. A single nudge, the right gravitational encounter, could send our planet adrift. Imagine a future in which Earth, torn from its orbit, sails away from the sun. The oceans would freeze, the air would grow brittle, cities would be buried under ice. Humanity, if it survived, would retreat underground, clinging to geothermal warmth, huddled in artificial caverns while the stars above burned cold and unreachable. It is a reminder that home is fragile, that stability is only an illusion granted by the balance of gravity. A shift in that balance, and even the most familiar world could become a rogue. Rogue planets unsettle because they embody exile. They are wanderers that no star claims, outcasts adrift in eternal night. Yet at the same time, they hold a strange allure. They are laboratories of hidden possibilities, places where physics and biology might write new stories. They remind us that the universe is not just made of bright, burning suns, but also of the silent, the lost, the unseen. And in this, they are mirrors of our own fears and fascinations. We wonder what it would be to live without light, without warmth, without the comfort of a center to orbit. We wonder whether we too, as a species, drift through the cosmos in search of belonging, uncertain if we are anchored or adrift. Rogue planets are metaphors as much as they are realities, teaching us that even in exile, there may be persistence, survival, perhaps even life. Take another moment to imagine it. Walking across the ice of such a world, every step crunching like broken glass, the horizon endless and black, the stars above so sharp they seem like holes in the fabric of night. No dawn will ever come, no sun will ever rise. And yet, beneath your feet, warmth flows upward, carrying with it the possibility of oceans, of strange beings, of life so different from our own that we would not even recognize it. A rogue planet is not just lonely, it is alive in its own way. Silent but not barren, a traveler carrying mysteries in its frozen heart. But the cosmos is not only filled with wanderers that drift. Some do not simply move. They haunt, their presence felt in ways that unsettle, as if the universe itself holds on to echoes of worlds and beings we cannot quite see. And it is toward these haunting mysteries that our journey must now turn. There are galaxies that glow with brilliance, spiraling whirlpools of stars that stretch across millions of light years, their arms glittering with suns like scattered diamonds. And then, there are galaxies that almost do not exist at all. Galaxies so faint, so nearly invisible, that they can slip past even our most powerful telescopes. Astronomers call them ghost galaxies, and the name fits perfectly, because they are like shadows of the galaxies we know, outlines without substance, apparitions drifting through the universe. To understand their strangeness, imagine a city at night. In a normal galaxy, every street lamp burns brightly, every window glows with life, the whole skyline ablaze with light. But in a ghost galaxy, only a handful of windows flicker, only a few lamps remain, and most of the city is swallowed in darkness. These galaxies are not teeming with stars. They are made almost entirely of dark matter, a form of mass invisible to us, detectable only by its gravity. They are skeletons of galaxies, filled not with light, but with shadow, silent structures haunting the cosmos. The discovery of ghost galaxies was almost accidental. When astronomers observed clusters of galaxies, they noticed something strange. Stars on the edges of these clusters moved as though they were being pulled by hidden giants, dragged by enormous, unseen forces. But when they looked for the source, no glowing mass of stars appeared. Instead, there were only hints, whispers in the movement of light that something vast but invisible was lurking there. These were galaxies almost without stars, galaxies made not of shining matter, but of something that does not shine at all. What makes them so eerie is not just their invisibility, but their abundance. For every galaxy we see with shining arms and radiant cores, there may be others, ghostly twins hidden in the dark. We know them not by sight, but by influence, like feeling the pull of an invisible hand. Their gravity tugs on neighboring galaxies, bends the paths of starlight, reshapes the flow of the universe, all while never revealing themselves directly. They are titans wearing cloaks of shadow, and they may outnumber the luminous galaxies we can see. Imagine drifting inside one. The sky above would be wrong. Instead of the crowded brilliance of stars filling the night, only a few faint points would shimmer, scattered like crumbs across an endless floor. Space would feel hollow, echoing with absence, as though the universe itself had forgotten to paint this part of the canvas. And yet, despite the emptiness, the gravity would be strong, holding everything in place with invisible chains. You would feel the presence of mass without ever seeing the source, as if you were walking through a cathedral whose walls were transparent, unable to grasp what holds the roof above your head. the physics behind them only deepens the mystery. Galaxies like our Milky Way glow with hundreds of billions of stars, their light a beacon across the void. Ghost galaxies, by contrast, seem to contain almost no stars at all. Some are so faint that a single star burns where millions should. Yet their mass is immense, outweighing their glowing fragments by factors of hundreds or thousands. This imbalance tells us that dark matter, the invisible substance that makes up most of the universe's mass, is their true body. In them, we are not seeing galaxies stripped of light. We are seeing the dark framework of the cosmos, laid bare. And so, ghost galaxies become a kind of revelation. They whisper to us that the universe is not what it appears to be, that the stage upon which stars burn is built of something deeper, stranger, and unseen. We tend to think of stars as the main characters in the cosmic story, yet ghost galaxies remind us that perhaps they are only decorations upon a scaffolding that is invisible but far more important. What else might be hidden in these veils of shadow? If ghost galaxies can drift unseen, then perhaps whole structures of the universe elude our vision. Filaments of dark matter may stretch across the cosmos like spiderwebs, shaping the motion of galaxies, weaving the architecture of everything we know, yet remaining beyond sight. The ghost galaxies are like fingerprints upon glass, smudges that give away a presence we cannot see directly. They tell us that the universe is haunted, not with spirits in the human sense, but with forms and forces that refuse to reveal themselves. The haunting feeling grows when we consider their role in cosmic history. Why do some galaxies burn brightly, while others remain dim? Did these ghostly ones fail to ignite stars in their youth, starved of the right conditions? Or did something extinguish them, stripping them of their light and leaving only the dark skeleton behind? In their silence lies a suggestion of fragility, that galaxies themselves can falter, that not every cosmic seed blooms into brilliance. For us, creatures who navigate by light, who depend on the warmth of a star to live, the idea of an almost starless galaxy is profoundly unsettling. We imagine galaxies as lanterns, as beacons scattered through the night of space. But ghost galaxies are more like shadows, telling us that the night itself is thicker than we thought. They remind us that most of the universe does not shine, that the cosmos is built less on radiance than on absence. Take a moment to imagine looking at the universe through eyes that could see dark matter. The glowing galaxies we know would become decorations, bright specks floating on top of a vast web of shadow. The ghost galaxies would stand revealed, not rare exceptions, but part of a deeper pattern, one in which darkness outweighs light. In that vision, the stars we hold sacred would seem like mere surface sparks upon a greater, hidden fire. It is easy to think of ghost galaxies as something separate, something alien to our experience. But in truth, they are tied to our very existence. Without the dark matter they reveal, galaxies like our own would not hold together. Stars would drift apart, planets would never form, and life as we know it could not exist. The ghosts, in their silence, are part of our story, unseen architects of the stage upon which we play out our fragile dramas. And yet, we cannot shake the question. What if there are things hidden within them that we cannot even begin to imagine? Could they harbor phenomena unknown to physics, forces, or structures that remain invisible not only to our eyes, but to our understanding? They are the universe's way of reminding us that we do not see the whole picture, that what we take for reality is only a fragment. Ghost galaxies are not frightening because they threaten us directly, but because they show us how much remains unseen. They tell us that the universe is not a finished book, but a palimpsest, written and erased, light layered over shadow, truth hiding behind invisibility. They force us to admit that most of the cosmos is beyond our grasp, a theater in which we watch only the glowing actors, while the stagehands and machinery remain cloaked in dark. And speaking of the unseen, ghost galaxies are only the beginning. For if whole galaxies can exist in near invisibility, then what does that say about the rest of the universe? Few concepts are more unsettling than the realization that most of everything we know, most of the universe itself, is not made of anything we recognize at all. Everything we touch, see, and feel is only a sliver of what exists. The trees swaying in the wind, the oceans shifting with the pull of the moon, the ground beneath our feet, Even our own bodies, all of it is made of ordinary matter, the atoms and molecules that seem to form the bedrock of reality. Yet, when astronomers weigh the universe, when they measure the rotation of galaxies and the bending of light across cosmic distances, they discover a profound imbalance. Ordinary matter, all the stuff we know and can touch, makes up less than a fraction of the cosmos. The rest, the overwhelming bulk of mass, is something else entirely, something invisible, intangible, and almost ghostly. This unseen component is what we call dark matter. The name is almost misleading because it is not truly dark in the way shadows are dark. Darkness is just the absence of light, but dark matter is not merely hidden, it is untouchable, unseeable, and yet undeniably present. Galaxies spin faster than they should. Stars at the edges whirl around with a speed that ought to fling them off into emptiness. They do not, because something holds them in place, a cosmic glue that outweighs all the visible stars combined. That glue is dark matter. Imagine trying to dance with a partner you cannot see or touch. You feel the tug of their hand guiding you. You feel the shift of their weight. But when you look, no one is there. This is how the universe behaves around dark matter. Its presence is betrayed not by light, but by influence, not by shining, but by pulling. Telescopes cannot catch it, detectors cannot grasp it. Yet galaxies move as though haunted by unseen partners. Scientists have tried to capture it, to corner it in experiments deep underground, shielded from cosmic rays and background noise. They build chambers filled with ultra-pure materials, waiting for the faintest nudge of a dark matter particle brushing against ordinary atoms. So far, the silence is deafening. Decades of searching have revealed only hints, whispers that vanish when examined too closely. Some theories suggest that dark matter might be made of undiscovered particles, ones that pass through us by the trillions every second without leaving a trace. Others imagine it as something stranger still, perhaps relics from the earliest moments after the Big Bang, frozen imprints of physics we have yet to comprehend. But the most unsettling ideas are the ones that drift beyond particles. What if dark matter is not matter at all, at least not in the way we think of it? Some physicists wonder whether it could be the shadow of hidden dimensions, extra layers of reality pressing invisibly against our own. Just as a two-dimensional creature living on a sheet of paper could not imagine the vastness of a third dimension towering above, perhaps we are bound to three, while other dimensions fold silently around us. Dark matter, then, might be the faint pressure of those hidden realms, shaping our universe from the outside. There is a poetic irony here. Humanity has always believed that what we see is what exists, that the shining stars and glowing galaxies represent the fullness of the cosmos. And yet, the universe whispers that we are blind. The visible universe is just the foam on the crest of a vast and unseen ocean, and what lies beneath is far greater than the surface waves. It forces us to admit that our senses, honed for survival on a small blue world, are utterly inadequate to comprehend the true shape of reality. Consider for a moment how this changes our perspective. When you look up at the night sky, you see countless stars scattered like dust across a dark canvas. But for every point of light, there is a halo of invisible matter holding it together. Every galaxy you glimpse is surrounded by a cocoon of darkness, a ghostly architecture that outweighs the stars it shelters. Even our own Milky Way is embraced by this invisible web, its stars cradled in the gravity of something we cannot see. In a sense, we are swimming not in light, but in shadow, existing within a structure whose scaffolding is hidden from view. This mystery is not merely scientific, it is existential. If the universe is mostly made of something we cannot perceive, then what does that say about our place in it? Are we like fish swimming at the surface of a deep ocean, believing that the shallow waves are all that exists, while beneath us lies a world more immense than we can fathom? Perhaps dark matter is not simply a scientific riddle, but a humbling reminder of our blindness, a reminder that reality is not obliged to reveal itself to us in familiar terms. The pursuit continues. Scientists launch satellites to map the faint distortions in cosmic light caused by invisible matter, creating cartographies of the unseen. They imagine new theories, from supersymmetrical particles to primordial black holes hiding in the darkness between stars. Each possibility is more haunting than the last, because each one implies a universe far stranger than we are prepared to accept. Maybe one day we will crack the secret, and dark matter will become as familiar as protons and electrons. Or maybe it will always remain beyond our grasp, a cosmic ghost we can only feel but never embrace. In that case, dark matter will not just be a scientific challenge, but a permanent scar on human knowledge, a reminder of the limits of our understanding. The question lingers like an echo in an empty hall. What is this substance that outweighs the stars, that sculpts galaxies, that cradles the universe in unseen hands? Matter, as we know it, is only half the mystery, for the rest lies not in mass but in energy, in the force that drives the cosmos apart, faster and faster, as though the universe itself longs to escape our grasp. At first, the universe seemed simple enough. It was born in a violent flash. It expanded, and like a stone thrown into the sky, it would one day slow, stop, and fall back. That was the story we told ourselves for decades. The Big Bang sent everything rushing outward, but gravity, the great gatherer, would eventually pull it all home again. Galaxies would slow their flight, stars would drift closer, and in the far, unimaginable future, the universe would collapse back into a fiery finale. It was neat, it was symmetrical, and it made a kind of poetic sense. But then came the shock. Astronomers peering into the distant cosmos discovered something unnerving. The universe was not slowing down. It was not even coasting at a steady pace. It was accelerating. Galaxies were not just drifting apart, they were being driven, as if some invisible hand were pushing them away from one another, faster and faster, stretching the fabric of space itself. This was not supposed to happen. It defied intuition. It defied gravity. To explain it, scientists invoked a name that was less an answer and more a placeholder: dark energy. Dark energy is not energy in the way we understand electricity or sunlight or motion. It is something subtler, stranger, woven into the very fabric of space. Imagine blowing up a balloon, only to find that it inflates itself without end, the rubber stretching further, the surface expanding faster, as though compelled by a will of its own. This is the universe we inhabit, a balloon not merely swelling but racing outward with acceleration that grows stronger as the cosmos becomes larger. We cannot see dark energy. We cannot touch it. Its fingerprints are found in the redshift of galaxies, the faint glow of ancient light called the cosmic microwave background, the delicate patterns in how galaxies cluster across billions of light years. Everywhere we look, the signs are the same. Some hidden presence is driving expansion, and it accounts for nearly 70% of everything in existence. That means most of the universe is not matter, not even dark matter, but this mysterious energy woven invisibly into the structure of reality. The implications are staggering. If dark energy continues to push, galaxies will keep drifting farther from one another until their light becomes too faint, too red, too stretched to ever reach us. The night sky will grow emptier, constellations will dissolve, and distant galaxies will vanish from view. One day, billions of years hence, our descendants, if they still exist, may look up and see only the stars of the Milky Way, alone in darkness, with no hint that a vast universe ever surrounded them. Cosmic history itself will be erased by the very force that drives it forward. But the future holds more than emptiness. The nature of dark energy determines the ultimate fate of everything. If it remains constant, the universe will keep expanding forever. Stars burning out one by one, galaxies growing dark, black holes evaporating slowly, until only a thin haze of particles drifts across an ever-growing void. This is the so-called heat death, an eternity of silence and cold. Yet dark energy might not be constant. If it grows stronger with time, the acceleration will not just pull galaxies apart, it will rip apart stars, planets, even atoms. The bonds that hold matter together could be undone in what some call the Big Rip, a finale not of collapse but of disintegration, where space itself tears everything into nothingness. On the other hand, if dark energy weakens or reverses, gravity may yet reclaim its throne. The universe could slow, halt, and fall inward, collapsing into the very opposite of the Big Bang. A big crunch, a fiery implosion where everything ends in the same blinding heat with which it began. Some even imagine this collapse might give birth to a new cosmos, a cycle of death and rebirth played out endlessly across time. We do not know which of these futures awaits us. Our theories are maps drawn in fog, outlines of a land we cannot yet see. We measure, we simulate, we imagine, but the true identity of dark energy remains hidden, a riddle whispered by the stars. Is it a property of space itself, a constant hum in the vacuum? Is it the influence of fields or forces we have yet to discover? Or is it a mirage, a misinterpretation of cosmic motion, masking some deeper, stranger truth? The uncertainty is haunting because it touches everything. Dark energy is not some distant curiosity. It shapes the very destiny of existence. It is the unseen tide carrying us toward shores we cannot yet glimpse. To live in a universe ruled by dark energy is to know that the ground beneath our feet is not fixed, but drifting, that the stars above are temporary neighbors, bound to vanish into unreachable distances. There is a strange beauty in this. The universe is not static, not still, not bound to some eternal sameness. It is alive with motion, restless, evolving, filled with forces we barely understand. Dark energy reminds us that the cosmos is not finished but unfolding, carrying us along in its vast current. Perhaps one day we will understand. Perhaps we will discover that dark energy is not an alien force, but a hidden aspect of reality, as natural as gravity once seemed mysterious. Or perhaps it will remain beyond our reach, a shadow in the equations, a reminder that the universe is larger and stranger than human thought can contain. For now, we are left with awe and unease. We live in a universe that is not only expanding, but accelerating, racing outward toward destinies we can scarcely imagine. It is a cosmos with a future written not in light, but in darkness, not in matter, but in energy we cannot see. And as we ponder this fate, as we wonder whether all will end in silence or fire or fragmentation, we come at last to the heart of the greatest question of all. For if the universe itself is driven by forces we barely comprehend, what does that mean for the one thing we measure most carefully, yet understand least of all? Time itself. We live our lives in the current of time. Seconds tick forward, days follow nights, years accumulate like sediment. The arrow of time feels absolute, undeniable, an endless march forward. We measure it with clocks. We anchor it to the orbits of planets. We feel it in our bones as we age. But what if this arrow is not as fixed as it seems? What if the forward motion we take for granted is only one direction along a far stranger road? Physicists tell us that time is intimately bound to entropy, the tendency of the universe to move from order into disorder. A sandcastle crumbles in the tide, not the other way around. A glass shatters when dropped, but never leaps back together on its own. Entropy gives us the feeling of time's passage, the sense that one moment leads naturally to the next, and that the future can never be confused with the past. And entropy is relentless. It drives the great engine of cosmic history, shaping everything from the formation of stars to the slow cooling of the universe itself. In the beginning, the cosmos was hot, dense, full of energy and possibility. Over billions of years, that energy spread out, thinned, diffused. Stars burned their fuel and died. Galaxies collided and merged. Radiation stretched into longer and weaker waves. Step by step, the universe has been moving toward a state of uniformity, where nothing more can happen because all differences are smoothed away. This is the ultimate fate described by physics, the heat death of the universe. A time so distant that the words we use for duration, years, millennia, eons, lose their meaning. In this future, stars will burn out one by one, leaving only faint embers of red dwarfs that glow for trillions of years before finally dimming to black. Galaxies will drift apart until no light bridges the void. Black holes, those ancient titans, will slowly evaporate through the whisper of Hawking radiation, vanishing into faint sighs of energy. And then, nothing. Not silence as we know it, for silence implies ears to hear it. Not darkness as we know it, for darkness implies eyes to see it. A nothingness beyond perception, a void where time itself ceases to matter because nothing changes. The universe will not die in a fiery cataclysm, but in a whisper, a fade into uniformity so complete that even the memory of difference disappears. To imagine this is unsettling, because it suggests an ending not with drama, but with absence. No final act, no great crescendo, only the slow extinguishing of all that ever was. The arrow of time, having pointed forward for billions upon billions of years, will stretch into irrelevance. For without events, without transformation, time loses meaning. What does tomorrow, signify if nothing can ever happen again. This concept challenges us on a deeply human level. We like stories with beginnings, middles, and ends. We seek closure, resolution, a finale that ties everything together. The heat death of the universe denies us that narrative. It offers only the image of a stage abandoned after the play, the lights dimmed, the theater empty, the script forgotten. No audience remains, no actors return, only a silent space where once there was life. Yet there is also a strange serenity in this vision. A universe that ends in violence feels hostile, but one that fades into stillness has a kind of peace. It is the peace of completion, of a story fully told, even if no one remains to remember it. Perhaps this is the true destiny of all things, not to be destroyed in fury, but to dissolve into quiet. Still, we cannot help but wonder, must this be the only ending? Physics leaves room for imagination. If entropy rules, then perhaps there are states of the universe we cannot yet comprehend, where time does not move in a simple, linear direction. Some theories suggest that in the far future, after heat death, quantum fluctuations might spark new beginnings. Out of the calm void, tiny irregularities could grow, eventually giving birth to new universes. Time's arrow might bend, or even reset, in cycles beyond our comprehension. Others speculate that the arrow of time itself could be an illusion, a property of how we perceive change rather than an absolute law. If so, then the universe may not be marching toward a single ending, but existing all at once, past, present, and future, spread out like a vast landscape. In such a view, death is not the erasure of time, but the coexistence of every moment forever. Whether or not these possibilities hold truth, they remind us that endings are not always absolute. The universe has reinvented itself before. From the ashes of stars came the elements of life. From the chaos of collisions came the structure of galaxies. From the death of one moment came the birth of the next. Time, whatever it ultimately is, has never been content to stay still. So perhaps the arrow we know, the forward march of entropy, is only one chapter in a longer story. Perhaps even when everything fades, when the stars have cooled and the galaxies have vanished, the universe is not finished. Perhaps it waits, silent and still, for another cycle, another rebirth, another chance to turn absence into presence again. We cannot know for certain. What we can do is marvel at the paradox. Time is both the most familiar and the most mysterious force in our lives. It carries us through childhood into age, through civilizations rising and falling, through the life and death of stars. Yet at its core, time may be as fragile and temporary as everything else, destined to dissolve into the silence it created. And so as we contemplate the arrow of time and the cosmic death it points toward, we must also leave space for another vision. An ending that is not an ending, but a turning, a cycle, a return. For as strange as the heat death appears, it is not the only story physics allows us to tell. There may be another path waiting beyond the horizon, one that takes us back to beginnings, to renewal, to birth. And so we turn toward that possibility now. The thought that endings may only be doorways and that the universe itself might be a circle, not a line. What if the universe is not a single unfolding tale, but a story told again and again? The human mind finds comfort in cycles. Day follows night, seasons return, civilizations rise and fall, and even in our own lives, we circle through beginnings and endings, joys and sorrows, births and deaths. It is perhaps no surprise, then, that some of the boldest cosmological theories imagine the universe itself as cyclic, endlessly expanding, collapsing, and being reborn in an infinite rhythm, like a great heartbeat echoing across eternity. For most of modern science, the prevailing view has been one of linear progression, a big bang, an expanding cosmos, and an eventual fate that ends in silence or collapse. Yet whispers of a cyclic universe have always lingered, both in scientific speculation and in mythologies far older than physics. Ancient Hindu cosmology describes kalpas, vast cycles of creation and destruction. The Stoics spoke of ekpyrosis, a fiery renewal of the cosmos. These ancient intuitions align strangely with certain modern theories, that perhaps the universe was not born once, but infinitely many times, each new cosmos rising from the ashes of the old. Imagine it, the Big Bang is not the beginning, but only the latest in a series of beginnings, each one ignited after the collapse of a previous universe. In some versions of this theory, the universe expands under the influence of dark energy until gravity finally reins it back in, collapsing everything into a final singularity. Then, from that singularity, a new Big Bang erupts, birthing a fresh cosmos. In others, quantum physics allows for a bounce, where instead of true collapse, the fabric of spacetime flips itself inside out, giving rise to expansion anew. This vision carries a strange poetry. Instead of a single fragile line stretching from origin to oblivion, reality becomes an eternal circle, with no true beginning and no final end. Every galaxy, every star, every planet, every life would not just vanish into history, but might, in some sense, return. The atoms that make up your body, already recycled through stars and oceans and air, might someday be reassembled in another you, another world, another version of this very moment. But what does it mean for existence if everything repeats? On one hand, it offers comfort. Death is not the final silence, but only a pause before the wheel turns again. The loss of civilizations, the fading of stars, even the eventual cosmic death we fear, none of these are ultimate. They are preludes to renewal, shadows before dawn. In a cyclic universe, there is always another sunrise. On the other hand, such repetition raises unsettling questions. If everything returns, does free will truly exist, or are we bound to live the same stories forever? The philosopher Friedrich Nietzsche explored this haunting idea in his concept of eternal recurrence, that each moment of our lives will play out again, endlessly, exactly as it has before. Imagine the weight of that thought, that the laughter you have shared, the grief you have endured, the choices you have made are not singular but infinite, echoing across cycles without end. Would that make them more precious or unbearably heavy? Science, for all its rigor, cannot yet answer whether cycles truly govern the cosmos. Observations of the universe's expansion suggest that dark energy may drive it apart forever, leaving little room for a grand collapse and rebirth. Yet even here, doubt lingers. We do not fully understand dark energy, nor the strange mathematics that govern the earliest moments of creation. Some models predict oscillations, subtle hints that expansion might someday slow, stop, and reverse. Others suggest that quantum laws might allow universes to sprout like bubbles from the froth of existence, each new one carrying echoes of the last. If cyclic universes exist, then we are living not in a singular history, but in a chapter of an endless epic. Every great event, the birth of galaxies, the rise of life, the flicker of consciousness, has played out before and will play out again. And not only once, but infinitely. Every breath you take has been taken before. Every star in the sky has burned and will burn again. We are at once insignificant, a moment in an infinite chain, and eternal, bound to reappear forever. Take a moment to imagine this not with fear, but with wonder. If this very instant will come again, then it is both fragile and infinite, both fleeting and timeless. The act of listening to these words, the beating of your heart, the turning of earth beneath your feet, each may be repeated across eternities. It is as if the universe were a great symphony, playing its melody over and over, each cycle a variation on a theme too vast for us to grasp. Yet perhaps the most mysterious implication is that cycles may not be identical. Just as seasons repeat but never unfold in precisely the same way, so too might universes cycle with variations. Maybe in one version, Earth never forms. In another, life thrives in oceans beneath the ice of distant rogue planets. In yet another, intelligence blossoms into civilizations that rise far beyond our own. If this is true, then the eternal return is not a prison of sameness, but an endless blossoming of possibilities, each universe a new flower in the cosmic garden. Whether comforting or terrifying, the idea of cyclic universes shifts our perspective. It invites us to see existence not as a line rushing toward an end, but as a circle, forever returning, forever renewing. It whispers that endings may be illusions, that death is part of a rhythm that carries on beyond imagination. And if this is so, then perhaps the ultimate mystery of existence is not whether the universe began or will end, but whether it has always been pulsing in this eternal rhythm, long before we appeared to notice it, and long after we are gone. But we need not wait for the rebirth of an entire universe to encounter strangeness. For even here, in the cosmos we inhabit now, phenomena exist that defy our understanding, teasing us with mysteries that feel as strange as new beginnings. And so, our journey turns from the eternal return of universes to the strange wonders already pulsing in the fabric of the one we call home. When most stars die, they fade quietly, dispersing their remains into the cosmos as dust and gas that may one day form new worlds. But some stars resist that quiet ending. They collapse violently until the atoms themselves are crushed into something strange, something that defies ordinary comprehension. These are neutron stars, the corpses of massive suns that, though extinguished, still radiate a kind of haunted power. To picture what a neutron star truly is, one must begin with an act of unimaginable violence. A star many times more massive than our sun burns through its nuclear fuel, fusing hydrogen into helium, helium into heavier elements, until at last it reaches iron, the cosmic dead end. Fusion no longer yields energy, and the delicate balance between outward pressure and inward gravity collapses. The star implodes. Its core is crushed. Its outer layers explode outward in a supernova brighter than billions of suns. What remains in the aftermath, when the fire has cleared, is a fragment of matter so dense, so alien, that words barely contain it. A neutron star. Here is the measure of its strangeness. A neutron star packs more mass than the sun into a sphere scarcely 20 kilometers wide. Imagine compressing an entire mountain range, the Himalayas themselves, into the size of a sugar cube. Or imagine holding a spoonful of its substance in your hand. It would weigh billions of tons, more than all the skyscrapers of Earth combined. The matter inside is no longer atoms as we know them. The crushing gravity forces electrons and protons to merge, leaving behind seas of neutrons packed so tightly that the very concept of solidity begins to break down. Its gravity alone is staggering. Stand upon the surface of a neutron star, if such a thing were possible, and you would be pulled downward with a force hundreds of billions of times stronger than Earth's. Even light, that fleet-footed traveler, would struggle to escape its grasp, bending and warping around the star like a moth caught in a storm. Time itself, near such an object, stretches and slows, as though the universe were bowing to the collapsed core's authority. And yet, it is not only gravity that makes neutron stars so haunting. They possess magnetic fields of ferocity beyond imagining, fields that can tear atoms apart and reshape the very vacuum of space. A single neutron star's magnetic field can be trillions of times stronger than Earth's. If one were somehow placed halfway to the moon, its magnetism would disrupt electronics on Earth. The most extreme examples, magnetars, are so intense that they could erase your credit cards from across half the galaxy. To call them stars is almost misleading. They are cosmic engines, compressed to a point of violent strangeness, radiating energy like lighthouses in the void. Indeed, many neutron stars reveal themselves as pulsars, spinning with incredible speed, beaming out jets of radiation like cosmic strobes. Some whirl hundreds of times per second, a rotation so fast that their crusts strain against the centrifugal force. To our telescopes, these pulsars appear as regular pulses of radio waves, ticking with metronomic precision across the cosmos. For a time, when pulsars were first discovered, astronomers wondered if they might be signals from alien civilizations. So eerily precise were their rhythms. In the end, they proved to be natural, but no less astonishing for that. The deeper one looks into these objects, the more surreal they become. Inside a neutron star, matter reaches states that cannot be recreated on Earth, not even in our most powerful accelerators. Do neutrons under such crushing pressure break down into a soup of quarks, the particles that make up protons and neutrons? Do entirely new phases of matter emerge, forms of existence we cannot yet imagine? Each neutron star is a laboratory, conducting experiments on the boundaries of physics, experiments we can only observe from afar. There is also a sense of warning in them, a reminder of the power hidden in the universe. The energy released when two neutron stars collide is so immense that it shakes the very fabric of spacetime, sending ripples of gravitational waves across the cosmos. These mergers forge elements like gold and platinum, seeding galaxies with the heavy atoms that make rings and circuits and crowns. Every piece of gold on Earth was born in such a collision, a relic of violence beyond comprehension. To hold a wedding band or a coin of gold is to cradle the echo of two neutron stars slamming together millions or billions of years ago. This duality is what makes neutron stars so strange. They are at once destroyers and creators, corpses of stars yet wombs of elements, warnings of death yet seeds of new beginnings. Their existence challenges us to see the cosmos not in terms of simple opposites, but as a place where endings and origins blur. Standing back from the science, consider for a moment the human response to such beings. We evolved on a quiet planet, lit by a single gentle star, surrounded by skies that seemed eternal. To learn that stars can collapse into such monstrosities is to confront the fragility of everything we thought permanent. It is to see in the heavens not only beauty but menace, not only order but chaos. Yet it is also to discover that even in collapse, creation continues, that destruction itself is woven into the fabric of life's story. Are neutron stars warnings, reminders of powers beyond comprehension, or are they stepping stones to new physics, gateways through which we might glimpse truths hidden from us until now? Perhaps they are both. Perhaps they exist to remind us that the universe does not conform to our categories, that it is more violent, more creative, and more strange than we dare to dream. Sometimes stars do not leave behind remnants of order at all. Sometimes they leave only chaos, wild and unpredictable, as if the universe itself were laughing at our attempts to impose meaning. To such chaos we now turn. When you gaze at the night sky, you might imagine that galaxies are scattered like coins tossed onto a floor, each floating alone in the vastness. But the truth is more intricate, more ordered, and more haunting. On the grandest scales, the universe arranges itself into a pattern that resembles a living structure, a web spun not by any creature we know, but by the mysterious interplay of gravity and dark matter. This is the cosmic web, the scaffolding upon which the universe hangs. To imagine it, picture a spider's web glistening with dew, stretched across the branches of some great unseen tree. Each drop of dew is a galaxy, or perhaps a cluster of galaxies, luminous beads hanging along invisible filaments. Between them yawns great emptiness, the cosmic voids we have already visited, oceans of darkness between the strands. What is striking is that this web is not chaos. It is a pattern, a tapestry woven with such precision that when astronomers simulate the birth and evolution of the universe on supercomputers, the resulting structures look uncannily like the actual maps of galaxies we see in the night sky. This web was not built overnight. Its story began in the earliest moments after the Big Bang, when the universe was still a roiling sea of energy and particles. Tiny fluctuations, minute variations in density so slight they might have seemed meaningless, were stretched by cosmic inflation into vast differences. Over billions of years, gravity gathered matter along these denser regions, pulling gas and dust together to form galaxies and stars. Dark matter, the invisible glue that outweighs ordinary matter 5-1, threaded through everything, guiding the flow of creation like an unseen hand. Where dark matter clumped, galaxies followed, lighting up the filaments like sparks in the night. What emerges from this process is breathtaking, an interconnected structure spanning the observable universe, hundreds of millions of light years across, yet delicate in its appearance. Clusters of galaxies gather at intersections, the nodes of the web, while thin bridges of light stretch between them. To fly through it in a starship, if such a thing were possible, would be like traveling inside an endless coral reef, where walls of galaxies arch and curve, while vast caverns of emptiness spread out in between. The scale of it is nearly unbearable to contemplate. Our own galaxy, the Milky Way, is but a single glimmering bead in one thread of this cosmic lace. Together with its neighbors, it forms part of a filament that itself joins with other filaments in a vast supercluster called Laniakea, a Hawaiian word meaning immense heaven. Laniakea is not just a collection of galaxies, it is our address within the universe, a reminder that we belong to something so large, so incomprehensible, that even our bravest metaphors falter. And here lies the mystery. Why this structure? Why filaments and not randomness? Why webs and not clouds? The answer may be nothing more than physics, gravity pulling where matter is slightly denser, dark matter shaping the invisible scaffold by simple rules repeated over cosmic time to yield an emergent pattern. Yet there is something unsettling about how much it resembles a living design. Filaments connect like neural pathways in a brain, like rivers in a delta, like the veins of a leaf. The universe, when seen at this scale, looks almost alive, as if some deeper law were weaving its strands with purpose. To stand back from such thoughts is to feel a profound unease. Are we witnessing the hand of chance or something deeper, something written into the very mathematics of reality? Perhaps the cosmic web is proof that order can emerge from chaos, that structure is an inevitable companion to randomness when enough time and gravity are given. But perhaps it whispers of something stranger, laws of the universe we only faintly glimpse, hints of a design we cannot yet interpret. The more we map this web, the more questions arise. Dark matter is the skeleton, but what of dark energy, that invisible force driving galaxies apart? Will it stretch the web until it thins and snaps, tearing filaments into isolated islands of galaxies drifting away from one another? Or will the web remain eternal, a frozen lattice holding the history of the cosmos long after its stars have burned out? The answers lie hidden in the same darkness that makes the web possible. What is certain is that this tapestry connects everything. Our galaxy is not an island, not even a continent, but a mere pearl strung on a thread that stretches for hundreds of millions of light years. Somewhere along another strand, another civilization might look out at their sky and wonder, just as we do, about the hidden patterns. To them, too, the universe would appear as a great woven fabric, binding them to us in ways neither of us can see, but both of us inhabit. And perhaps that is the deepest meaning of the cosmic web. It is not just a structure of galaxies and dark matter. It is a reminder that we, fragile and fleeting though we are, belong to something unimaginably vast, a pattern that stretches beyond the limits of sight, perhaps beyond the limits of time. To find our place in that web is to accept that we are both insignificant and essential, a single thread in the greatest tapestry ever woven. As we trace the filaments and map the nodes, as we peer deeper into the darkness, we find ourselves arriving at the greatest mystery of all, not the structure of the cosmos, but the question of our own place within it. What does it mean to be a conscious knot in this fabric of light and shadow? The answer, like the web itself, stretches into darkness, waiting for us to follow. When we stare into the night sky, it is easy to imagine we are simply observing something outside ourselves, something detached, something distant. Stars, galaxies, nebula, points of light burning far away, objects to be cataloged, measured, named. But the longer we look, the more difficult it becomes to pretend that the cosmos is only an external spectacle. The universe does not just sit out there, waiting to be discovered. It reflects back upon us, turning our gaze inward, even as it stretches outward into infinity. Every mystery we uncover in the cosmos has a way of transforming into a question about ourselves. When we wonder whether life exists elsewhere, we are really asking whether we are unique, whether our existence has meaning, or whether we are merely one flicker among countless billions. When we marvel at the birth and death of stars, we are really marveling at the fragile brevity of our own lives, at the inevitability of our own endings. When we contemplate dark matter and dark energy, we confront the uncomfortable fact that most of reality is invisible to us, not only in the cosmos, but in the depths of our own minds. It is as though space itself is a mirror held by eternity, reflecting our questions back at us in forms too vast and too strange for easy answers. To ask, what is the universe made of, is also to ask, what are we made of? The atoms in our bodies were forged in the hearts of stars that exploded long before Earth ever existed. Every breath we take contains molecules that have traveled across oceans, across continents, through generations of life. The same carbon that forms our bones and skin once lit up the skies as starlight and will one day again drift into space to become part of something new. When astronomers chart the expansion of the universe, measuring galaxies as they drift farther and farther apart, the hidden question is whether we too are expanding away from one another, whether the great silence between stars is mirrored in the silences between human beings. The cosmos becomes metaphor as much as reality, a stage on which we project our fears and our hopes. Its enormity unsettles us because it reflects our own smallness, but it comforts us too, because it whispers that smallness does not mean insignificance. Even a single spark can illuminate darkness, and even a single life can carry meaning within immensity. To look into deep space is to confront fragility. The Earth itself, Our home is little more than a pale dot suspended in blackness. Everything we love, every memory, every story is balanced on this fragile sphere, orbiting a star that is itself temporary, burning its way toward eventual death. Yet within that fragility lies wonder. The fact that consciousness has emerged here, on this small rock circling one of billions of suns, means that the universe has become aware of itself. Through us, the cosmos is not only expanding, it is reflecting, thinking, questioning. The mysteries of space mirror the mysteries of our own existence. Consider the question of whether we are alone. At one level, it is a scientific question. Do other intelligent civilizations exist among the stars? But at another level, it is an existential question. Are we truly isolated beings, or are we, in ways unseen, connected to something larger than ourselves? To ask whether there is life elsewhere is to reveal our longing not to be solitary, our hunger for connection, our fear of being adrift in an indifferent void. And what of time? The arrow of entropy, the eventual heat death of the universe. These are not only cosmic forecasts, but also intimate reminders. Just as stars fade and galaxies dim, so too do we age, so too do we fade. To study the future of the cosmos is to study the fate of our own bodies, our own memories, our own legacies. It may sound bleak, but there is also beauty in this recognition. For if everything is temporary, then everything becomes precious. A star's brilliance is no less magnificent because it is finite, and a life is no less meaningful because it will one day end. Some people look into the abyss of space and feel despair. They see only emptiness, only indifference, only the crushing weight of infinity. But others look and feel the opposite. They see belonging. They see connection. They realize that if the atoms in their hands were forged in stars, if their breath carries the history of the Earth, if their thoughts are shaped by the same laws that guide galaxies, then they are not separate from the universe at all. They are participants in it, expressions of it, inseparable from its unfolding. Perhaps this is the secret the mirror of the infinite reveals, that we are both fragile and vast, that we are both fleeting and timeless, that while our individual lives are small, we are also strands in a pattern so immense that it defies comprehension. When we look into the depths of space, we are not gazing into a void, but into a reflection of ourselves, our questions, our fears, our hopes, scattered across light years. In this way, the universe does not diminish us, it enlarges us. To recognize our place within it is not to feel erased, but to feel woven into something beyond measure. The storm of existence may be endless, and we may be sparks within it, but those sparks illuminate the darkness in ways that matter. The fact that we can even ask these questions, that we can wonder at all, means that consciousness itself is part of the universe's story, as real and as vital as the galaxies strung across the cosmic web. So when you next lift your eyes to the night sky, remember that you are not just looking outward, you are also looking inward. Every star is a reflection, every question about them, a question about yourself. To wonder about the infinite is to wonder about the finite, to confront the mystery of being alive here, now, at this fragile, fleeting moment. And perhaps that is the greatest revelation of all, that in seeking to understand the universe, we are really seeking to understand ourselves. The cosmos is not only vast and cold, it is also a mirror, and in its depths, eternity gazes back. The mysteries of deep space are not just curiosities for astronomers, they are lullabies of silence, stretching across light years, echoing with questions too large for any one mind to hold. We've drifted through voids and shadows, through black holes and bursts of impossible light. We've touched invisible matter, felt the pull of dark energy, and wondered at the destiny of time itself. Each segment is a fragment of a larger truth, that the universe is not only stranger than we imagine, but perhaps stranger than we can imagine. And yet, in this strangeness, there is beauty. There is a reminder that existence is fragile and precious, that silence can be profound. That mystery itself is a kind of gift. So, as you drift toward sleep, let your mind float freely like a rogue planet between stars. Let the weight of galaxies soften into nothing more than a quiet hum at the edge of thought. The universe does not demand answers tonight. It only asks that you wonder. Sleep now, for the cosmos will keep its secrets until tomorrow.